Thanks. Awesome. Hey, everybody. We flew in from Salt Lake City, so hopefully you will enjoy our talk. If you don't, I guess it is what it is.
And can everyone hear us in the back?
Yeah, can you hear us okay?
Audio check.
Back,
good.
great. Good, cool. All right, fundamentals of data engineering. What is it? Who's heard of this book, by the way? Awesome. Cool. So let's get going. So I guess why did we write this book, Matt? I mean, what were some of the things?
I think there were a number of motivations. One of those was trying to answer questions for our consulting clients. And so, Joe got a request to write a book from a publisher, and then we talked together about doing it. And we realized that this could help to answer a lot of questions that we get over and over again. And then a second big motivation was helping to train a new generation of data engineers. And one of the transitions that Joe and I went through, which I think a lot of people in this room went through, was the transition from the Hadoop world, from the previous big data world, into this new cloud-based data engineering stack. And that has been a very tough transition. Yeah. And it's also been hard for people coming into the field to find information about how to train as data engineers.
Let's talk about this real quick. We like to give a quick shout out to Matt Turk for giving us the inspiration for the book. So who's seen this before, right? Who can make sense of this? Who has 15 years of experience in every one of these technologies, right? It's insane. And so, gonna let Matt take a picture of that real quick. No, but seriously, this is insane. But this is a landscape that you're trying to navigate as a data engineer or a data practitioner in general, right? I mean, who here looks at this and says, I get it. Like this is the space, and I can navigate this with ease. I want to keep this very conversational too, so we're going to be asking you a lot of questions, and raise your hands or just throw things at us. It's fine. We're used to it. No, but in all seriousness, is there a new one of this coming out, by the way, or? It's okay. So anyway. So this actually gave us a lot of inspiration, though, right? Because if you're a data professional, how the hell do you make sense of this thing, right? So some of our motivations, right? So data engineering was not well defined. We felt like the definitions were very tool-centric, technology focused and whatnot. You go on Google, and it's like, what is data engineering, Matt? It's like...
Yeah, exactly. And I'll kind of skip a bullet point and then go back. But like this one right here, what we kept hearing a lot is that data engineering is Spark, or data engineering is Kafka.
Or Hadoop.
Or Hadoop, further back. And at some point, technology is important, but if you can't figure out how to use technology to serve your business customers and to get work done and to deliver working AI models, then it really doesn't matter. And people were getting lost in this kind of focus on technology.
Yeah, does this sound familiar to anybody in the room? Yep. Technologies. And also, the weird thing is there's no standardization of skills and knowledge. I think this is actually true in the data field in general. Data teams right now are assembled basically very ad hoc. If you tried to create a sports team the way you created a data team, it would be insane, right? I mean, think about it. It's like, okay, so you can kick a ball, you can sort of run, you can sort of listen to instructions once in a while. That's kind of how we form data teams today. There's very little standardization of knowledge, right? And so for data engineering, we don't even have a definition for it yet, or no, we do actually with the book, but there's no standardization of skills and knowledge for data engineering teams. So it's interesting. Data engineering is the fastest growing field as of a couple years ago in some report from DICE. But it's like nobody knows what the hell it is, right? Isn't this kind of weird, right? So, and also vendor marketing noise. It's cranked to 11. So, I mean, who here feels that they can get a coherent answer on data products these days? Or do you run to a lot of vendor pitches and marketing and that kind of stuff, right? Thanks, Lauren.
Lauren is a plant. So
I think that the essence of what we were trying to do is focus on, okay, so we were tasked to write this book. We wanted to write a book that was going to be relevant 5-10 years from now, right? So think about this for a second. You're trying to define a field, and you're also trying to figure out the things that aren't going to change. Does this sound easy? Hard? I don't know. Yeah, it was hard.
I mean, kind of, but I think what Joe and I realized as well is that a lot of the core issues in data engineering actually haven't changed that much in 20 years. And so people got so excited about technology in the transition in the 2000s, the internet bubble, the rise of Google, the rise of Facebook, that they lost sight of that. And so our question was, could we distill data engineering down to fundamentals and then take that as a framework where you take the fundamentals first and then you slot technologies into that instead of going in the other direction?
Which happens a lot, right. So what doesn't change? The fundamentals of data engineering. Let's talk about this. I'm going to make this, kind of an, Q&A live. What do you think data engineering is? I'm just going to ask the group over here. What is data engineering?
Data wrangling.
Data wrangling? Right. What does that mean?
Just trying to organize your data so you can put it into a model or algorithm and run some jobs against it.
Right, trying to organize data so you can do stuff with it. Anyone else have an idea of what data engineering? Making sense of a mess. I like this. That's
Alex talked about exhaust, right? And that's still a reality. Even though we have nice platforms like Snowplow, we still have to deal with a lot of exhaust. And exhaust is not pretty, and it's a hard job.
Very hard. Yes.
To first understand what engineering is, then turn that knowledge to data.
So it's a hard one, right? Engineering, data engineering. Here's our definition. I'll just leave this up here for like a few seconds for you, and then I'll give the TLDR. Basically, you get data from sources, you do something with it, and then you serve it. Like that's basically about it, right?
But it's true, right? I mean, I think, again, if you went through the big data era, there was just so much excitement. Like, big data is going to change everything, change the entire world. And then what did a lot of us see? What was a very common experience with data lakes? What happened to a lot of that data?
Became a mess.
Yeah. In many cases, I mean, I've worked in companies like this. It just turned into a data swamp. And that's because, in spite of the amazing technology we had, we kind of lost sight of these fundamental things.
Right. I mean, it's just as easy, right? You just get data and do something with it and serve it, right? So I'm sure now that you know this, you'll just be really proficient data engineers, and we can stop our talk. But and so a few of the motivations behind this is, it was a not a really daunting realization, but a very obvious thing that needed to be said, that data engineering is not just about technologies, right? This runs counter to things, though, because if you're an engineer, what do you want to do? It literally is said in your title. You want to engineer stuff, and so you want to focus on technologies. And all too often, what do we see, Matt?
So I think what we've seen again and again in our consulting practice and also in previous jobs is that focus on technology ends up distracting from the real goal of what data engineering is all about. And I think fundamentally, one of the big threads that runs throughout our book is that data engineers need to also learn to essentially be business people. And that doesn't mean that they have to have MBAs. It doesn't mean that they have to just focus on like metrics and financial numbers, but they do need to understand who their customers are and understand what they're delivering for those customers. And then if you can build technology, if you can engineer things around those needs, then you'll start to be successful as a data engineer. And so, for example, going back to the previous talk about Snowplow, I think that's exactly what's made you guys so successful, because it's not just about having this like amazing streaming technology. It's like, what, at the end of the day, at the end of the pipe, what's going to happen to this data? Everything is built around that fundamental idea.
Exactly. Data engineering is lifecycle management. Who's heard of data lifecycles? Raise your hand. Alex, what's a data lifecycle? To put you on the spot here.
Sometimes like bronze, silver, gold, but it's kind of the life cycle of the data, different stages it goes through in terms of being more trusted or more governed or higher quality.
Who else has an idea of what a data life cycle is? Tony, actually. I'll just walk over here. You have climbing shoes. Those are nice ones. I like that.
I'll say that it also includes what its lineage is, who consumes it, how it's consumed.
Yep. I like that a lot. Matt, what do you think a life cycle is?
I guess that's what we're going to put up here on the screen in just a second.
Yeah, we'll talk about that in a minute.
But I'll tell you before we put the next couple slides up, we actually found some inspiration from some of the cloud vendors. I know that the cloud vendors have a reputation for building up a lot of hype, but sometimes they also talk common sense. And in particular, Google Cloud had this notion of a data lifecycle. Where does data typically start? Like, what's the beginning of the pipes? If we're trying to get from like the beginning out to the end, what's the starting point for a data lifecycle?
Yeah, exactly.
The pipe has an input, basically.
Right.
And that can be something like a customer interaction online. It can be a CRM platform. It can be a SaaS product. It can be interactions with an ad.
Right.
Yeah.
Exactly. And so, you know, Lifecycle is something that came to mind when we were writing the book, right? So we were trying to think, okay, so again, back to what doesn't change. Data moves. Things happen to it. It keeps moving around. And you know, ultimately somebody uses it. But that's not the only thing, right? Then you know, you take that information and you do something with it, right? I mean, that's the whole point of this. So you don't just like land data inertly. Well, you could actually, but it's not really useful. Yeah. And so, you know, life cycle is a really big thing that we kept thinking about. And then, you know, in our work, we kept noticing. So Matt and I call ourselves recovering data scientists. So it's sort of a joke and sort of not. I mean, we've been in recovery for a while now as data scientists. But okay, so who here has done analytics or machine learning? It's okay, a lot of people. How many times have you, I guess, gone to, you know, started a job or started a project, and the data wasn't there, or you needed to set up the infrastructure to get the data? Has anyone had this experience before, or was the data already there for you? A few people here. Interesting. Well, you work at great companies, and I'm happy for you.
That was other people's job.
That was other people's job. They had data engineers, right? But what we kept seeing over and over was, especially during the 2010s with the data science hype cycle, was the you know, companies would hire data scientists like Matt. What's your background, Matt?
I actually have a PhD in math, and then I got into data science, and I ran into exactly these problems, right? So no matter how good you are at statistics or machine learning, it's hard to make sense of data without having some quality inputs.
Right, same thing. You know, I also have a background in math and doing machine learning for a very long time, and get hired, and it's kind of like, well, now you're a data scientist, and you can obviously do magical things. That's why we hired you. You're a scientist of something like that. But, you know, you show up, and then, you know, in my case, it's like, well, we were just kidding, actually. We have to also build the systems to get the data, and so forth. And so we kept noticing this pattern over and over again. What we, you know, the other thing that we figured didn't change is that data engineering is foundational to good data outcomes. Without, you know, proper infrastructure, you basically have toy science projects and so forth, right? Sound familiar? Right. This leads us to, I guess, the essence of the book, right? So this is the data engineering lifecycle. So, Matt, you want to explain the top part?
Yeah. So over here, generation. Back to basically what Ethan was saying. You start with some kind of input. It can be a customer interaction. It could be events coming out of snowplow. There are all kinds of ways that data gets generated. But the point is, data engineers need to be very focused on this step, because if the data quality they get here is not good, no amount of technology is going to fix that. If your data inputs are bad, there are limits to what you can do downstream in terms of cleansing. Then you get down here to ingestion. You have to somehow get data into your systems. And transformation. And I think what happens a lot in the transformation stage is that we focus a lot on transformation technologies, right? So sometimes salespeople will call it feeds and speeds. How fast can my system transform data? But what we really care about is that those transformations are high quality. And so yes, data engineers need to think about technology, but really they need to think about high quality delivery down here to the serving stage. And serving is not, again, just about technology. It's about the what and the whom is going to be receiving that data. So what's the use case, and who are the stakeholders for that use case?
Yeah, and also underlying the entire thing is storage, right? So data stored when it's ingested in some form or another, whether it's a cache or whatever, stored when it's transformed, it's stored when it's served, right? So take into account these major building blocks. This should seem obvious once you see it. When you ask data engineers about the life cycle, I think it was shocked at how many times we'd get blank stares.
Or we get like things like, well, it's really all about Spark. Or data engineers really need to know Spark, or they need to know Python, or they need to know Pandas or Snowflake or whatever technology it is.
Right.
It's like those are all great technologies, but what really is the essence of your job? Right.
And I mean, yeah. And again, this should be like almost tautologically like just blindingly obvious. But again, what we really focus on. Okay, so in 5 years, I mean, are systems going to stop generating data? Right? Under what scenario would that ever happen? Or when are you going to not ingest data into something, or store it, or transform it, or or serve it. Like I would love it. I would love it. If somebody has an idea of when that wouldn't happen, I would love to talk about it. But in most use cases we've seen, I would say in all of them, this is sort of the building blocks. That's about it. But there's also the undercurrents, right? So when we're writing the book, we're like, okay, so where would security go, or data management, or governance, or ops, or architecture, right? Orchestration and software engineering. We're like, is that it doesn't, security doesn't just exist in generation, right? And it's kind of undercuts like the entire life cycle. I'm sure people have heard of some pretty famous hacks recently where things have gone bad. So you really want to pay attention to security. Same with all these other things. And this is just, so data engineering as a practice really focuses on both the life cycle and the undercurrents, right? So, is there anything you want to add to that? Or?
Oh, maybe I actually will emphasize security, but I could emphasize all of these. What's the typical business outcome when data engineers don't care about security? What is a possible business outcome that you might expect?
You're in the news.
You're in the news.
Is that a good thing for you? No. What's that? Not in a good way. No.
Exactly
there's some things you want to be known for, and there's some things that are career-ending that you don't want to be known for. Security breaches, and you maybe being responsible for that, is certainly one of those things.
Yeah.
So.
Yeah, I think with data management, what we saw in the big data era is people did not care about this. Data management, like, we don't need that. Just throw it all in the lake. It's going to be awesome. What was the consequence of that? Well, in practice, what we saw is things like sometimes what's called the warn pattern. Warn pattern is write once, read never. Data would just go in there and it would never come out again. Mm-hmm. And so now we're seeing a return to this kind of focus, right? I think in 2022, people care way, way more about data management than they did in 2012, because there's this realization that this part of engineering generates a lot of value, because this is where your data actually becomes useful if you can manage it.
Sure, but we also notice everything goes in pendulums, right? So data management was a very unsexy thing to talk about back in the big data era, because it's all about how big is the data, right? What can I do with that? But it's a pendulum in the sense where you go this direction, but then everyone over here, the data management people, are saying, well, but you're not being strict enough with the data, and all, like what happens if you don't manage it and govern it and so forth. And then the pendulum swings back, which it is right now. Data modeling is back in vogue all of a sudden, right? All these discussions about data catalogs, for example. This is a few years ago, data catalog was like, nobody would talk about this. It was like, oh, what? No, we're not doing that. But now it's vogue because people realize you need discipline around the data, right? Same with ops. Data ops is very popular and growing, and architecture and orchestration and so forth, right? All these have their own pendulum swings, but they're all important in the data engineering lifecycle. And so we have about 5 minutes left. I would like to just open up the questions here. You can get a hold of us here. I can stand out of the way if you would like to connect with us on LinkedIn. Take a picture. If you don't, that's fine too. What questions do you have? Or jeers or comments or...
Yeah.
This is more of a complaint than it is than anything else. If data engineering is the focus, as in, crafting the narrative from the business problem to the solution you're about to serve and then back again, why do people still look for those esoteric things amongst data scientists? Like, hey, do you know, like, this particular modeling strategy or that particular modeling strategy, when actually, being a battle-scarred data scientist myself, I realized that that's really not what people are after. What they're really after is how to understand the journey of the data, much like, a good scientist would. So why is that disconnect still there? Just thinking about trends of hiring people in general.
This is a good question. I feel like, and Joe, I'll be curious to hear your thoughts as well, but I feel like when we advertise data science, and to some extent data engineering as a career, we focus a lot on the prestige of this career. And therefore, it's a focus on like how exciting the mathematical algorithms are and how quickly the field is moving. And in that initial training of data scientists and the way we advertise the career, I don't think we focus enough on like the actual job of a data scientist, which is to deliver value for the companies that employ them. I don't know. What are your thoughts on this?
I mean, there's a lot of novelty around data science still, right, as a job. And I mean, okay, so here's a fun question for the audience. What is data science? Whoever answers this, well, okay. Any answer gets a free book, which we have over there, limited to the first 10. Yeah, data science, what is it? Linear regression. Okay, no, I mean, seriously, I'm curious, right? It's the same, okay. Understanding patterns? Yeah. I like that. He gets a book. And he gets one too. 2 books. It's kind of like Oprah, but we don't give away cars. But right, okay. So data science. You first got to start with from first principles. Like, what is a definition, right? And so I think a lot of the confusion is, well, okay, what is a data scientist, and then what are they supposed to do, right? If you can't define what the job is, and how the hell are you supposed to understand what its role is, right? Data science means different things to different companies and different teams and different people, right? And in a lot of cases, what we saw is data science as a term started getting co-opted. I mean, you can start with the DJ Patel's original sort of quasi-definition in 2009, and Drew Conway's Venn diagram of like hacking stats, domain expertise, and so forth, and bring it to now. Back when I got into data science in like 2010 or 2011 or whatever, or actually way before that one, but anyway, if the new school data science, it was all about machine learning, right? Now, I don't even know what it is, because it could be analytics, it could be a bunch of other stuff, and like, so what we saw is just a lot of, I think, like title stuffing, right?
Where there was a lot more focus maybe on the prestige than the actual job of data scientists once again, right?
Yeah,
Everyone
I mean,
wanted
would
this
you rather
title.
be called a
Yeah.
BI analyst or a data scientist? Which one pays more money? I think you have your answer. Yes. Real scientists get paid even less than data scientists. Yeah, it's sort of like, I don't know. I joke with Matt. It's sort of like a sandwich artist at Subway calling himself an artist. It's just the term has just been I think kind of
Diluted.
diluted.
There's a lot
Yeah.
of dilution.
I don't know what it
going
is.
on. Yeah.
And in fact, I think candidly, data engineering will suffer the same thing. It will happen. We write about this in the last chapter of our book, and the fact that data engineering as a title could morph into something else. But that's what titles do. And so I don't know if we answered your question or just thoroughly confused you, but that's fine. That's what we do best. Of course. Yes, Lauren.
Thank you, Matt and Joe, my 2 good friends. If I'm an analyst or an analytics engineer, I know BI tools, I know some SQL, how that all works. What are the 2 or 3 things I can do to move towards the data engineering profession, to become that data engineer?
So I think part of it is one thing Joe and I see all the time. Over and over again, we see tools get abused. And what I mean is that people will take like Snowflake and do a whole bunch of single row inserts into it. And what happens is these tools, like if you do that, they become very, very expensive and they perform very, very poorly. And so in many cases, the difference between just doing analytics and doing actual engineering is actually just understanding how the tool works and how to optimize it. And so then collecting metrics about how the tool is operating, and collecting metrics about what's costing you money, and then finding hotspots and optimizing those hotspots. It's a lot of very classical stuff, actually. It's almost like the job of the DBA for the older on-prem database systems.
Yeah, but understanding your tools, I mean, that's just like,
Yeah.
you should do that. I mean, you're a craftsperson, right? But the other thing I would say is if you're coming from analytics or data science and getting into data engineering, like learn software engineering.
Yeah.
Learn the principles of like writing good code, writing performant code, writing code that looks great and beautiful and you're proud of it. Learn to test and debug. Like, software, it's interesting in data because all we're basically doing in this industry is just reappropriating stuff that software engineers have been doing for like the last 10, 20 years, right? As practices. So my advice, I posted something short the other day on YouTube about this, but I said, look, because I got this question like twice last week from analysts and data scientists. Like, I want to become a data engineer. How do I do that? And I was like, well, if you're really good at the data part, then you got that covered, right? But what you probably lack is like rigorous software engineering skills. That's what I would focus on, hands down. So.
And then on top of that, I'll add that you need to develop systems thinking. And so systems thinking means that instead of thinking about running queries, You want to get like a holistic picture of how your pipelines are working from beginning to end, and how they're orchestrated, and what the bottlenecks are, and operationally, can you collect metrics on those things, going back to the earlier discussion. Yeah.
Right. Well, any other questions?
Yeah, thanks. I was just curious, could you talk a little bit about how to keep your data infrastructure from becoming kind of a monolithic part of your ecosystem that can't switch? For example, if you look at like what Walmart did with Teradata, I think they incubated Teradata, but now they're switching off of it. If you look at Nielsen, same thing with some of these legacy databases. How do you stay flexible? A company like Nike might be a good example, where they're not really tied to one OLTP or one OLAP. How do you build that into your data engineering culture?
So hopefully I heard most of the question, and then correct me if I missed something here. But I think fundamentally the question is, like, as an organization, how do you essentially embrace flexibility so you can advance your technology stack, among other things? Okay. Yeah, so I think there are a couple of things here. So sometimes Joe and I sometimes it's too easy to change technologies. And this is something that's responsible for like a lot of horrifying AWS bills and horrifying Snowflake bills. We sometimes call this the curse of familiarity. And the curse of familiarity is that most new technologies are designed to look like something you've seen before. And so you're like, oh, it's Snowflake. It just runs SQL. It's just like Teradata. But it's actually not just like Teradata. And so I think organizationally, you want to embrace that change, but then you also want to make the appropriate investments in training and in operations to actually understand the tools that you're transitioning to.
Did that answer your question?
You probably have a response here too. What are your thoughts?
I don't have much to add. I think that was actually really good. Yeah. Rashad, can you pass the mic over to Rashad? Or thanks. I think one more question, and then we'll wrap it up. Yep. Everyone can spell the pizza, so yes. Yep.
So I lived through the transition from ETL to ELT to reverse ETL, and I always, when I see things like that or other changes in industry, I always wonder what kind of underlying factors lead to these transitions, because I don't necessarily think that people just get smarter and suddenly realize that they were doing it the wrong way before. I feel like there's some kind of changes in technology, and I have this pet theory that it's bottlenecks, that when the bottleneck changes, that's when the strategy changes from ETL to ELT or whatever. I'm just curious if you could describe a little bit about why that transition happened, because I don't know.
Do you want to know the transition from ETL to ELT, for example, or just in general, like kind of why do we have phase changes? And well, I mean, so ETL, it started with Bill Inman back 1989 or something like that, and that was a response. He talks a lot about transformation still to this day, why it's important to transform data, right? And so, but in a lot of cases, transforming data in the systems in 1989 were it was very difficult to do. I mean, it's not like today where you can just spin up resources and transform data, right? It was like these were mainframes or like very resource-limited OLTP systems. So that was the rise of the ETL and the data warehouse. And then around the time of Redshift came out, and suddenly you had cloud. And the possibility of running things much more cheaply and storing your data. And so the question started coming up. Well, do I need to do ETL, or can I just land my data and then transform it after? Right. The data lake paradigm also ushered this in. Then reverse ETL, or I call it BLT, bidirectional load transform, which I think is way cooler. But that's an interesting one. I mean, anyone who's been data engineering for a while has already been doing this. You're just sending data back into the destination, right? This is not a new thing. It's good marketing, but that's the practice. But what's interesting right now is the discussion is actually moving back to ETL. I'm starting to see more and more discussions about how ELT is a bad paradigm. And again, remember when I talked about pendulums? The pendulum, again, is swinging back to ETL. And why? Why is this? Well, all too often what you find is people will just land data and probably never transform it. And then what's the point of that? We just land data, and then what do you do with it? And so, there's I'm starting to see a lot of discussions around ETL coming back. And I think the other thing that's causing this to come back into discussion is real-time and streaming transforms. Right, that's the other big change. So, good question. Okay, great.
Just to follow up on your last comment, I'm curious why you don't want to focus on definition based on technology and tools, given that there do seem to be cyclical natures in data and data technology, and fundamentally at the end of the day, you're talking about slow storage versus fast compute and optimizing between those two.
Let's see, make sure I understand this. I think I think, and correct me if I misunderstood the question, but I think when we talk about not setting definitions around technology, we mean specifically not saying that data engineering is about Spark, or not saying that data engineering is about Hadoop, and trying to define broader technology categories instead. And I think that's what Joe and I specifically saw as our careers evolved, is that they would define data engineering to be a very specific technology stack. And so in 2022, you could do this by saying, well, data engineering is really about ingesting data with, 5-parameter over stitch.
DBT or
and then it's about DBT, and then it's about Snowflake. And I think what we wanted to focus on instead is saying, fundamentally, whether you're using Spark or Snowflake, they can serve somewhat different use cases. Like if you need to do a lot of low-level data wrangling that's not SQL suitable, then you're probably going to use Spark. But a lot of people end up using Snowflake, and fundamentally, those technologies are not so different. And so don't get attached to a very particular stack and define that to be data engineering. Think in terms of broader paradigms and more flexible paradigms, and then choose the technologies that serve the use case that you have. I don't know, did that answer your question? Okay.
All right, the really last question then. All right.
Thank you. Hi. First of all, congratulations to both of y'all for publishing this wonderful book. It's rare that I get to speak with such amazing authors who have published such great stuff. So I'm really curious, what was your personal favorite chapter in this book? This question is for both of you, and why?
I think for me it was the one about architecture, and would you say that was our hardest chapter?
Okay, here's another quick question for you. Who can define architecture? I'm killing you guys tonight. But that was by far the hardest chapter, because we knew it would be the most controversial too. Architecture is one of those squishy terms where you're never going to get that chapter right, and somebody's going to be pissed off about it, right? I would say that was the hardest. That was the most fun and probably the challenging. There's a section on data modeling too, which I was like, ooh, this is going to draw a lot of guns out. Okay, so who's been paying attention to data modeling as a discussion point right now? It's crazy, isn't it? These people are nuts. It's like you're talking about like cult leaders, and it's like these clashing religious sects and stuff like that, and it's nuts. These people are crazy. The Kimball crowd over here, if you don't get it absolutely right, they're going to slay you. Same with Data Vault over here. Like if you don't get that right, like you're toast. And so that was also challenging. Like I had Bill Inman personally review the section on data warehousing, for example. I was like, does this pass what you say it is? And he's like, you missed a spot, but here you go, and now it's good. And so I would say that was the hard part and the fun part. And the fun part too is just talking to experts in the field. Like you get to talk to all your heroes and just talk to them about the parts of the book that you're writing about, their stuff. So that was a lot of fun.
Yeah, I think it was architecture, and it was a really tough chapter to write. But I don't know, why was that one fun? I think we got to encounter a lot of interesting ideas in the domain of architecture, and hopefully distill them down into something interesting, some kind of synthesis of a few ideas. So,
all right, on this note, thank you.